Hello everybody, this is Philip Jonas at Kalamazoo Valley Community College, presenting OpenStax Principles of Economics. And today we are going to cover sections 3.4 and 3.5, price ceilings, price floors, and efficiency. In this module, you will learn to explain price controls, price ceilings, and price floors. Contrast consumer surplus, producer surplus, and social surplus. Explain why price floors and price ceilings can be inefficient. And analyze demand and supply as a social adjustment mechanism. In this module, we are talking about price controls, which refers to situations where the government puts limits on prices rather than letting the market adjust freely. The two most common types of price controls are price ceilings and price floors, referring to the idea of a maximum higher than which the price isn't allowed to go, a ceiling, or a minimum that's the least you can charge for a product. Let's start out by talking about a price ceiling example in the market for apartments. You will often hear this referred to as rent control. So let's say we live in a city where currently the apartments are renting for $500 each, and we've got 15,000 rental units being rented. So as always, equilibrium quantity, both quantities supplied and demanded. But change is coming. Our successful city is attracting lots of people to come move here. So we expect the demand for rental units to increase. If we let the market handle this adjustment, here's what we can expect. An increase in demand will lead to higher prices. Let's say rent goes up to $600. And of course, this higher price, even though the supply curve itself didn't move, is going to move us along the supply curve to a point where there's a higher quantity supplied. Law of supply in action, leading us to a new equilibrium where 17,000 people are living in a rental unit paying $600 each. So this change is coming, and our existing 15,000 renters are not happy at all. They don't want their rent to go up. And they successfully managed to convince our city to put a limit on rent prices, a price ceiling. They don't want that rent to go any higher than it was already at $500. So we're going to draw that in as a horizontal line in our model of demand and supply, labeled a price ceiling. At first, at the original equilibrium, that price ceiling doesn't have an impact. The natural market outcome is $500. The law says $500 is okay, so the law doesn't do anything yet. But of course, as we have people coming to our city and demand increases, now that price ceiling is going to have an effect. In the absence of the price ceiling, we would see the price climb to $600 at a new equilibrium. But now the law says no, price stays at $500. So let's see what happens at the $500 price. Quantity supplied, of course, is unaffected. Same price, same supply curve, same quantity supplied. 15,000 apartments available in our city. But the demand curve is at a whole new place. So at that same $500 price, we now have 19,000 people who want to live in those apartments. That's not an equilibrium. Quantities demanded and supplied aren't in balance. And as you know from a previous module, when the quantity demanded exceeds the quantity supplied, we refer to the result as a shortage, or sometimes excess demand. So what does that mean for our market for rentals? We have 4,000 individuals that want to look for an apartment. 19,000 are looking total, 15,000 find one. We have 4,000 that cannot find an apartment. Does that mean all of our renters are in bad shape? Well, no. The ones that do have an apartment, 15,000 right here, don't see their rent go up. So they're pretty happy about that situation. It should go without saying that over on the supply side, all landlords are unhappy with this price ceiling. If the price ceiling didn't exist, they would have more rental units and earn higher rent. So that is strictly negative for them. As such, a price ceiling is a first example of a policy that produces both winners and losers. Let's go ahead and look at the same situation from the perspective of a demand schedule. So our original supply and demand curves here, S0, D0, now represented as a table. And our original equilibrium, of course, 15,000 supplied and demanded at a rental price of $500. And now we've got people coming to our city. Demand increases to D1, which is no longer in an equilibrium at $500. To find that new equilibrium, we are looking for the row where quantity supplied and quantity demanded in the new column are equal. That's going to happen at $600. But not if we have the price ceiling in effect, right? Price ceiling means rent stays at $500, even though S0 is now combined with demand D1. So having a look at the numbers there, at a $500 price, we've got 15,000 units on offer, 19,000 units in demand, leading to a shortage of 4,000 units. We can tell a similar story about price floors. Let's do this one a little bit more in the abstract. Let's say we are being asked to analyze the likely impact of a price support for wheat in Europe. Let's say the European Union has decided to deploy some funds so that wheat farmers make more money. We can represent this price support as a price floor, a minimum price above the current equilibrium. Let's draw that in. Once again, we've got a horizontal line. Since both price ceilings and price floors are represented as a horizontal line, make sure to put a label on them so that, everybody knows what we're talking about. So the equilibrium price would be down here at P0, but the law says can't do less than PF. Let's have a look at our curves. We of course find a not equilibrium situation here. Demand produces a lower quantity demanded than the equilibrium quantity at that price floor, while quantity supplied is higher. This mismatch, this imbalance, is this time referred to as a surplus or excess supply. So we predict if we set a wheat price support above the equilibrium price, we will end up with a surplus of wheat. And that's probably where the government's spending some money because it's going to have to buy up that extra wheat and destroy it, or else the farmers are going to be quite mad if the price floor prevents them from selling the wheat in the first place. So this is the basic story of price floors and price ceilings leading to an imbalance in the market if they make the equilibrium illegal. Really, where economics comes in is to analyze the efficiency of such policies. Economics is the study of efficient resource allocation. And our primary measures of efficiency are referred to as consumer and producer surplus. We'll find other measures later as well. Consumer surplus is the idea of contrasting what is a consumer paying for a product versus how much would they have been willing to pay. If they can find a product for less than what they would be willing to pay, we consider the difference consumer surplus. So for example, you go to the store, you want to buy yourself a nice birthday cake. And you have worked out, hey, I think I'm willing to spend like up to $30 on this. So if you go to the store, the birthday cake's more than $30, you say no thank you, but if it's $30, you'll buy it. You go to the store and you find the birthday cake is only $20. In this situation, we would say you're earning a consumer surplus of $10 because you're getting a product that is worth $30 to you. You're getting it, but only paying $20. It's about that difference. Likewise, producer surplus, by the way, whose relationship to the profit of a company we'll look at in a future module, is calculated as the difference between what a seller would have been willing to accept for a product versus what they actually get. Let's say you're selling a car. You've worked out for yourself, hey, I'm going to post this car for sale, and if I find somebody that'll give me $10,000 for my car, that's as low as I'm willing to go. I'm still going to sell it at $10,000, but if I can't get $10,000, I'm not going to sell it. But then somebody comes along and they offer you $15,000 for your car. So you say, yes, thank you. You do the transaction, and we would now say you have earned $5,000 worth of producer surplus because you have sold a thing for $15,000 that you would have been willing to let go for just $10,000. So these are the general ideas of consumer and producer surplus. But the real beauty of this approach is that it integrates super nicely with our model of demand and supply. So here's a product, any product. And currently, in a state of equilibrium, this product is selling for $80. That's the actual price. Now this demand curve here represents all the different buyers in our market and the prices at which they are willing to buy this product. So for example, down here we've got somebody that values the product at less than $80, so they are not even buying. But over here, lots of buyers. Let's focus on a specific one. Let's call them Buyer J. Buyer J is willing to pay up to $90 for the product. Currently, though, the product is only $80. So we would say Buyer J is earning $10 worth of consumer surplus when buying this product. And we can generalize that further by looking at every single buyer along this demand curve and taking the difference between their price and the actual $80 price paid. We get an area, here labeled F, which is the area below the demand curve, but above the price. This area represents total consumer surplus for all the buyers in this market who are buying the product. How do we calculate that area? Well, this is a demand curve, right? So to find the area under that curve, we'd need some calculus. We'd have to calculate an integral. We're going to stay away from that. We're just going to say, underneath the demand curve, above the price, there's our consumer surplus, and somehow you'd even be able to attach a number. Let's do the same thing for our sellers. So again, let's look at our supply curve. Lots of potential sellers here. Some have a reservation price higher than $80. They don't even sell. Lots of other ones, they are selling the product. Let's focus on the specific seller, seller K. They'd be willing to accept just $45 for the product. But they can actually sell it for $80. A very good deal for seller K. That means we would say seller K is earning $35 worth of producer surplus through the sale. And if we want to generalize that, we take all of our selling sellers, represented by this section of the supply curve, and subtract their reservation prices from the $80 price actually paid. Thereby we find an area, here labeled G. It's below the price and above the supply curve. This area G represents producer surplus for all of our sellers. So one more time, let's put that together. In this market, if we let the market exist at an equilibrium, we identify consumer surplus below the demand curve above the price, that's area F, and producer surplus below the price and above the supply curve, that's area G. We could also say that social surplus is the combination of those two. These measures, consumer and producer surplus combined into social surplus, is our primary measure of efficiency in economics. We say a market is efficient if it produces as much of the social surplus as is possible. If, on the other hand, a market produces a quantity that is not efficient, that produces a lower amount of social surplus than what is possible, we would say however much social surplus is lost, that's a deadweight loss. So if efficiency is the goal of economics, you might think of deadweight loss as one of our enemies. If we encounter deadweight losses, often we want to see if we can make them smaller or get rid of them. So that brings us back to our topic of price controls. Here we have a market at equilibrium. $600 product, 20,000 units being sold. Now here's a question. How does the efficiency of this market change if we put a price ceiling at $400? So a law that says you can't charge more than $400 for this thing. So now it's not going to be selling for $600 anymore. It's going to be selling for $400. We already discussed the impact on quantities. At this lower price, we find that quantity supplied falls and quantity demanded increases. But one of those numbers is more important than the other one. In order to have a sale, you need both a buyer and a seller. So when you have a mismatch between quantity supplied and demanded, how many sales actually happen? Answer: whichever one is the lower one of those two numbers. So where previously sellers wanted to sell 20,000 units, now they only want to sell 15,000 units. Doesn't matter how many units buyers want to buy, that's gonna limit our sales to 15,000 units in the market. Notice we've got a dashed line here going all the way to the top of the demand curve. What's going on there? Well, I'm going to label some areas here that are formed, and we can use those area labels to compare consumer, producer, and social surplus, both at equilibrium and with the price ceiling in effect. So let's start out with our baseline here. Price is at $600. The price ceiling is not in effect. One more time. Consumer surplus is the area below the demand curve, above the price. So we look at our areas here. We've got all these buyers buying. Willingness to pay higher than $600. So the difference between those willingness to pays and the $600 price point, we have areas T and U representing consumer surplus. So that's the same area as in the previous graph. Now I've just split it up into two separate areas, and you'll see why in just a second. Likewise, if we look at our sellers, everywhere below the price and above the supply curve, we now find this hopefully somewhat familiar area split up into three letters, V, W, X, representing producer surplus. So our baseline before the price ceiling is in effect is that social surplus is equal to all labeled areas, which, by the way, fun fact, you can demonstrate that this is the maximum amount of social surplus you can get out of this market. So we would call it efficient in economics. Now, let's put this price ceiling into effect. So now the price is at $400, and we have to pay close attention to what's happening to consumers here. At first, we might be tempted to say, hey, if we look below the entire demand curve and above the price ceiling, we find a huge area. But not so fast. Consumer surplus only happens if buyers can actually buy the product. And as I mentioned before, can this many buyers buy? No, we're limited by the quantity supplied. Sellers are only offering 15,000 units for sale. So even if we assume that those units are going to the buyers who are willing to pay the most, once we hit this dashed line, consumer surplus stops because none of the other buyers are getting the product. So we look below the demand curve, above the now $400 price, but only for the buyers that can actually buy, the first 15,000 buyers. What do we find? Areas T and V. V is new. Let's talk about V for a second. So our 15,000 buyers here, these 15,000 can buy both when there's a price ceiling and when there's not. However, without the price ceiling, they're paying $600. So their consumer surplus for these first 15,000 is T. With the price ceiling, they're only paying $400. So now consumer surplus is bigger. Same willingness to pay, price falls, bigger difference. That means for these 15,000, consumer surplus actually increases from T to T plus V. But before that price ceiling, we had some more consumers that were buying. Before that price ceiling, we had 20,000 sales. So we've got some more buyers here that used to buy at the $600 point. Now at the $400 point, totally still want to buy, can't get any product. The consumer surplus that's associated with those buyers, area U, that's gone from consumer surplus. Consumer surplus changes from T and U to T and V. You can tell in this specific example, as a group, the buyers are still better off. The gains, V, outweigh the losses, U. This is often the case when you lower prices for consumers, that they come out ahead, unless we put that price ceiling really, really low so that barely anybody can get the product anymore. Now let's look at our sellers. How do they feel about the situation? Not good. We look below the new $400 price, above the supply curve. Only area X remains. Sellers lose both area V, the 15,000 units that they still sell, now sell for a lower price. Lower price, same supply curve, less difference, less producer surplus. And in addition to that, it used to be that sellers sold 20,000 units. They don't anymore. So whatever producer surplus was associated with these 15,000 units, with these 5,000 units that are now gone, area W also disappears from producer surplus. So let's sum up this social surplus. Social surplus now amounts to areas T, V, and X. Basically, because the quantity is now lower, social surplus ends at an earlier line. Without the price ceiling, social surplus encompassed all areas between demand and supply all the way out to 20,000. Now, it only encompasses the areas TV and X between demand and supply out to 15,000 units. So from the economic perspective, we would say, hey, we've got ourselves a deadweight loss here. The most social surplus that could be produced by this market, TUVWX, if there's no price ceiling, is no longer occurring. Now social surplus, TVX, is a lower amount. Or in other words, U and W are lost, are a deadweight loss. Of course, in addition to that, with the social surplus that still occurs, TVX, we had some changes in the distribution there. T and X were part of consumer and producer surplus under both scenarios. But V changes hands. Without the price ceiling at $600, V is part of producer surplus. With the price ceiling at $400, V is part of consumer surplus. So V is a loss to producers and a gain to consumers. That's why we don't call it a deadweight loss. A deadweight loss, like U and W, is a loss that's gone for everybody. It's gone from social surplus. Areas changing hands might be losses and gains to specific groups, but not deadweight losses. This means that from an economic perspective, this price ceiling introduces an inefficiency. Next, let's have the same discussion for a price floor. So here's another market, currently in equilibrium at $8, 1,800 units. And we want to talk about What happens if we introduce a $12 minimum price, a price floor? So again, the market's not going to be in equilibrium anymore, right? Quantities supplied increase, quantities demanded decrease, and if those two aren't in match, how many transactions actually happen? Well, you know it. It's the lower of the two numbers. You need a buyer and a seller. So the number that's really of significance for us here is what's this new quantity demanded, 1400 units, because that's how many sales actually happen. Let's draw on that dashed line and then use it to label some areas. Once again, we want to compare. How do our efficiency metrics look at the original market price of $8? So let's look at our consumers. Under the demand curve, all the way out to 1800, above the $8 price, we find areas G, H, and J. For our producers, we look below the price, above the supply curve, all the way out to 1800 units, we find areas I and K. Adding them up, we are left with a social surplus of all labeled areas, which, once again, that's the maximum social surplus we can get out of this market, so we go ahead and call that efficient. Now, let's put the price floor in effect. You can no longer sell the product for $8. The minimum price now is $12. And, crucially, that means the number of sales falls from 1800 units to 1400 units. Once again, doesn't matter that sellers would like to sell way more now, we're going to need a buyer and a seller for each transaction. So whatever happens, it's going to stop at 1400 units. Let's check in with our consumers first. Consumers, not happy. Prices are up and they are buying less product. Instead of having areas G, H, and J underneath the demand curve and above the price, we now find underneath the demand curve and above the $12 price only area G. On the other hand, potentially good news for producers, higher prices. Just be careful not to overcount. Even though sellers would love to sell a whole bunch more product, they can only sell what they've got a buyer for. So their sales end at 1400 units. Don't count producer surplus past that line. But let's see what we can find up to that line. Underneath the price, above the supply curve, we now have areas H and I. So I, of course, was already part of producer surplus before, but H is new. Those 1400 units are now selling at a higher price. Of course, a little bit gone from the producer surplus as well. Area K was associated at the $8 price with these next 400 units. Those don't get sold anymore. No producer surplus there. Producers lose area K. However, as is the case in this picture, often a price floor will make producers better off, unless we set it like really, really high so that they can barely get any sales anymore. Let's look at this from the social perspective though. After all, economics is a social science. Once we add up all our areas, we find that with the price floor, social surplus is reduced to only areas G, H, and I. J and K are no longer part of social surplus, and as such, we would label them a deadweight loss. In addition to that, within the social surplus that still exists, GHI, H changes hands. It's a loss to consumers, but a gain to producers. Once again, because social surplus falls, we would label this outcome as inefficient. That concludes our discussion of sections 3.4 and 3.5. In this module, you learned how to explain price controls, price ceilings, and price floors, how to contrast consumer, producer, and social surplus, how to explain why price floors and price ceilings can be inefficient, and to analyze demand and supply as a social adjustment mechanism. I will see you next time.